Welcome to our comprehensive journey into the world of statistics. Today, we'll explore the essential concepts that form the backbone of data analysis and interpretation. Statistics is more than just numbers, it's a powerful tool that helps us make sense of the world around us. Whether you're a student, a professional, or simply curious, understanding statistics can open doors to new insights and informed decisions. In this video, we'll break down complex ideas into easy-to-understand segments, ensuring you gain a solid foundation. Let's embark on this adventure and discover how statistics shapes our daily lives and the decisions we make. Statistics is the science of collecting, analyzing, interpreting, and presenting data. It provides us with methods to summarize large amounts of information and draw meaningful conclusions. From predicting weather patterns to understanding market trends, statistics is everywhere. By learning the basics, you'll be able to interpret data more effectively and make better decisions in both your personal and professional life. Let's dive deeper into the core components that make statistics such a vital field. Statistics can be broadly divided into two main types: descriptive and inferential. Descriptive statistics help us summarize and describe the features of a dataset, while inferential statistics allow us to make predictions or inferences about a population based on a sample. Understanding the distinction between these two types is crucial for anyone working with data. Throughout this video, we'll explore both types in detail, providing examples and practical application. Descriptive statistics involve methods for organizing and summarizing data. Common tools include measures of central tendency, such as the mean, median, and mode, as well as measures of variability like range and standard deviation. These techniques help us get a quick overview of the data and identify patterns or outliers. By mastering descriptive statistics, you'll be able to present data in a clear and meaningful way, making it easier to communicate findings to others. Inferential statistics go beyond simply describing data. They allow us to make predictions or generalizations about a larger population based on a sample. Techniques such as hypothesis testing, confidence intervals, and regression analysis are commonly used in inferential statistics. These methods are essential for scientific research, business forecasting, and many other fields where making informed decisions is critical. At the heart of statistics lies data. Data can come in many forms, from numbers and measurements to observations and survey responses. The quality and type of data collected directly impact the accuracy and reliability of statistical analysis. Understanding how to gather, clean, and organize data is the first step in any statistical process. Let's look at the different types of data and why they matter. Data can be classified into two main categories: qualitative and quantitative. Qualitative data describes qualities or characteristics such as colors or labels, while quantitative data involves numbers and measurements. Each type of data requires different methods of analysis and visualization. Recognizing the type of data you're working with is essential for choosing the right statistical tools and techniques. The process of collecting data is a critical step in statistics. Reliable data collection methods ensure that the information gathered is accurate and representative of the population being studied. Common methods include surveys, experiments, and observational studies. Each method has its strengths and limitations, and the choice depends on the research question and available resources. Once data is collected, it needs to be organized in a way that makes analysis possible. This often involves creating tables, charts, or graphs to visually represent the information. Proper organization helps identify trends, patterns, and anomalies within the data. It also makes it easier to communicate findings to others, whether in a report, presentation, or discussion. Data visualization is a key aspect of statistics. By using graphs, charts, and other visual tools, we can make complex data more accessible and understandable. Visualizations help highlight important patterns, relationships, and outliers that might be missed in raw data. Choosing the right type of visualization depends on the data and the message you want to convey. Measures of central tendency are statistical tools used to identify the center or typical value of a dataset. The most common measures are the mean, median, and mode. Each provides a different perspective on what is considered average in a set of data. Understanding these measures helps summarize data and compare different datasets effectively. The mean, often called the average, is calculated by adding up all the values in a dataset and dividing by the number of values. It's a simple yet powerful way to summarize data. However, the mean can be affected by extreme values or outliers, which is something to keep in mind when interpreting results. Median is the middle value in a dataset when the values are arranged in order. It's especially useful when data contains outliers, as it's less affected by extreme values. The mode, on the other hand, is the value that appears most frequently in a dataset. Both measures provide valuable insights, especially when used alongside the mean. Measures of variability describe how spread out the values in a dataset are. Common measures include range, variance, and standard deviation. These tools help us understand the consistency or diversity within the data. High variability means data points are spread out, while low variability indicates they are clustered closely together. The range is the difference between the highest and lowest values in a dataset. It gives a quick sense of the spread but doesn't account for how values are distributed. Variance, on the other hand, measures the average squared deviation from the mean, providing a more detailed picture of variability. Standard deviation is a widely used measure of variability. It tells us how much the values in a dataset typically differ from the mean. A low standard deviation means most values are close to the mean, while a high standard deviation indicates greater spread. This measure is crucial in many fields, from finance to science. Probability is a fundamental concept in statistics, representing the likelihood of an event occurring. It's expressed as a number between 0 and 1, where 0 means impossible and 1 means cert. Probability helps us make predictions and assess risk in various situations, from games of chance to business decisions. Probability distribution describes how the probabilities are distributed over the values of a random variable. Common distributions include the normal distribution, binomial distribution, and Poisson distribution. Understanding these helps in modeling real-world phenomena and making informed predictions. Sampling is the process of selecting a subset of individuals from a population to estimate characteristics of the whole group. Common methods include random sampling, stratified sampling, and cluster sampling. The choice of sampling method affects the accuracy and reliability of statistical conclusions. In statistics, a population includes all members of a defined group, while a sample is a subset of that population. Analyzing a sample is often more practical than studying the entire population. However, it's important to ensure the sample is representative to draw valid conclusions. Hypothesis testing is a method used to determine whether there is enough evidence to support a specific claim about a population. It involves setting up a null hypothesis and an alternative hypothesis, then using data to decide which is more likely. This process is fundamental in scientific research and decision-making. Confidence interval is a range of values that is likely to contain the true value of a population parameter. It provides an estimate of uncertainty and is often expressed as a percentage, such as a 95% confidence interval. This concept helps quantify the reliability of statistical estimates. Correlation measures the relationship between two variables, indicating whether they move together. However, correlation does not imply causation. Just because two variables are related doesn't mean one causes the other. Understanding this distinction is crucial for interpreting statistical results accurately. Regression analysis is a statistical technique used to model and analyze the relationship between variables. It helps predict the value of one variable based on another. This method is widely used in economics, business, and social sciences to forecast trends and make informed decisions. Statistical significance indicates whether an observed effect is likely due to chance or represents a real difference. It's commonly assessed using p-values. A result is considered statistically significant if the p-value is below a predetermined threshold, such as 0.05. Errors are an inevitable part of statistical analysis. Common types include sampling errors, measurement errors, and bias. Understanding the sources and impacts of errors helps improve the accuracy and reliability of statistical conclusions. Minimizing errors is a key goal in any statistical study. Outliers are data points that differ significantly from other observations. They can have a major impact on statistical analysis, sometimes skewing results or revealing important insights. Identifying and handling outliers appropriately is essential for accurate data interpretation. Data cleaning is the process of correcting or removing inaccurate, incomplete, or irrelevant data. Clean data is essential for reliable statistical analysis. This step often involves checking for errors, handling missing values, and standardizing formats to ensure consistency. With the rise of technology, the amount of data generated has grown exponentially. Big data refers to extremely large datasets that require advanced tools and techniques for analysis. Statistics plays a crucial role in making sense of big data, uncovering trends, and driving innovation. Ethics in statistics involves ensuring data is collected, analyzed, and presented honestly and responsibly. This includes respecting privacy, avoiding manipulation, and being transparent about methods and limitations. Ethical practices build trust and credibility in statistical findings. Statistics is widely used in business for decision-making, forecasting, and performance analysis. Companies rely on statistical methods to understand customer behavior, optimize operations, and identify market opportunities. Mastering statistics can give businesses a competitive edge. In healthcare, statistics is essential for analyzing clinical trials, tracking disease outbreaks, and improving patient care. Statistical analysis helps medical professionals make evidence-based decisions and develop effective treatments. The impact of statistics on public health cannot be overstated. Educators use statistics to assess student performance, evaluate teaching methods, and improve educational outcomes. Data-driven insights help schools and policymakers make informed decisions that benefit students and communities. Statistics is a powerful tool for advancing education. Sports teams and analysts use statistics to evaluate player performance, develop strategies, and predict outcomes. From baseball to basketball, data analysis has transformed the way sports are played and managed. Fans and professionals alike benefit from statistical insights. Governments rely on statistics for policymaking, resource allocation, and public services. Census data, economic indicators, and health statistics inform decisions that affect millions of people. Accurate statistical analysis is vital for effective governance and planning. Scientific research depends on statistics to design experiments, analyze results, and draw conclusions. Whether studying biology, physics, or social sciences, statistical methods ensure findings are valid and reproducible. The scientific method is closely tied to statistical analysis. Statistics isn't just for professionals, it's part of our daily lives. From tracking expenses to interpreting news reports, we use statistical thinking to make choices and understand the world. Developing statistical literacy empowers us to make smarter decisions every day. There are many misconceptions about statistics, such as believing that correlation always means causation or that averages tell the whole story. Understanding the limitations and proper use of statistical methods helps avoid these pitfalls and leads to more accurate interpretations. As technology advances, the field of statistics continues to evolve. New tools, techniques, and applications are emerging, making it easier to analyze complex data. The future of statistics is bright, with opportunities in artificial intelligence, machine learning, and beyond. Learning statistics can seem daunting at first, but with the right approach, anyone can master the basics. Start by understanding key concepts, practicing with real data, and applying what you learn to everyday situations. Resources like online courses, textbooks, and tutorials can help you along the way. Statistical software makes it easier to analyze and visualize data. Popular tools include Excel, SPSS, R, and Python. These programs offer a wide range of functions, from basic calculations to advanced modeling, making statistical analysis accessible to everyone. Interpreting statistical results requires critical thinking and context. It's important to consider the limitations of the data, the methods used, and the real-world implications. Clear interpretation ensures that findings are meaningful and actionable. Effective communication is key to sharing statistical findings. Use clear language, visual aids, and concise summaries to make your message understandable. Tailoring your communication to your audience ensures that your insights have the greatest impact. Statistics is a dynamic field that benefits from continuous learning and improvement. Stay updated with new developments, refine your skills, and seek feedback on your analyses. Embracing lifelong learning ensures you remain effective and relevant in the world of statistics. We've covered the essentials of statistics, from basic concepts to real-world applications. Statistics empowers us to understand data, make informed decisions, and drive progress in countless fields. As you continue your journey, remember that statistics is not just about numbers, it's about discovering meaning and making a difference.